A system resource is a tool used by either hardware or software to communicate with each other. When software wants to send data to a device, such as when you want to save a file to a hard drive, or when the hardware needs attention, such as when you press a key on the keyboard, the hardware or software uses system resources to communicate. There are four types of system resources: memory address, input-output addresses, interrupt requests, and direct memory access channels. When we press a key on the keyboard wants to tell the CPU that a key has been pressed, but CPU is already busy doing something else. So the keyboard places a voltage on IRQ line assigned to it, and this voltage serves as a signal to the CPU that the device has a request which needs processing. An operating system relates to memory as a long list of cells that it can use to hold data and instructions, somewhat like one-dimensional spreadsheet. Think of a memory address as a seat number in a theater. Each seat is assigned a number regardless of whether someone is sitting in it. The person sitting in a seat can be data or instructions, and the OS does not refer to the person by the name but only by the seat number. For example, the operating system might say, I want to print data in memory address 500. These addresses are most often displayed on the screen as hexadecimal number in segment offset form. Input-output addresses, which are simply called ports, are numbers the CPU can use to access hardware devices in much the same way it uses memory address to access physical memory. The address bus on the motherboard sometimes carries memory addresses and sometimes carries input-output addresses. If the address bus has been set to carry input-output addresses, then each hardware device listens to this bus. For example, if CPU wants to communicate with keyboard, it will place the input-output address of keyboard on address bus. Once address is placed, CPU announces input-output addresses are on the address line. Now all input-output controllers listen for their address. Hard drive controller says, not my address. Floppy disk controller says, not my address. But keyboard controller says, it's mine, I will respond. Input-output address lines on a bus work much like an old telephone party line. All devices hear the addresses, but only one responds. Another system resource used by hardware and software is a direct memory access channel, a shortcut method that lets an input-output device send data directly to memory bypassing the CPU. Some devices such as the printer are designed to use DMA channels, and others, such as the mouse, are not. DMA channels are not as popular as they once were because their design makes them slower than newer methods. However, slower devices such as floppy drives, sound cards, and tape drives may still use DMA channels. So basically, hardware devices calls the CPU for attention using interrupt request. Software calls a hardware by input-output address of hardware device. Software looks at a memory as a hardware device and calls it with memory address. DMA channels pass data back and forth between hardware device and memory. So that's how the hardware communicates with software.